remind me about the synapse before we walk through these steps. Do you remember the essay for the first exam?
Yeah.
Okay. So action potential comes down the axon.
Mm-hmm.
What happens when it gets to the presynaptic terminal? Remember, this is the language.
So you want us to mention?
Calcium
Yes. So
Calcium?
what about calcium?
gets released.
Well,
No.
yeah.
Enters.
So there are calcium channels that have to
Open.
Very good. And these are voltage sensitive, right?
Yeah.
So calcium channels open, calcium goes in, and what does calcium cause?
The release. No. Yeah, the
Right.
releasing
The
the
what? Exocytosis,
Yeah.
vocab word. But what is that?
The vesicles.
Vesicles that have what in them?
Neurotransmitters.
Okay, right. So the vesicles and the neurotransmitters migrate down, fuse with the presynaptic membrane, release their contents, right? So then we get diffusion of the neurotransmitter across the synapse, and now what has to happen?
Bind
Binds to
the postsynaptic
postsynaptic
cleft space.
Neuron.
Receptor.
receptors.
There we go.
Receptors, right? Because if you're sending something, something has to receive it. So just remember
What
that.
the hell are you talking
Receptors.
about? Yeah.
Sorry, I know I'm up in your face.
I keep looking at you when I see a llama. I think that's
Yeah, it's actually, read it, it's really cute.
That is really cute.
Yeah.
So yes, so you bind to receptors, right?
Yeah.
And ultimately now what you're going to do is produce a change on that neighboring neuron.
Mm-hmm.
You're going to either do an EPSP or an IPSP, right? Fire, fire, don't fire, don't fire. All right, so you bind a receptor. If you activate the receptor and it's coupled to an ion channel, let's just keep it simple.
Okay.
If that ion channel is chloride, what do you get?
IPSP.
Very good. And if it's potassium, IPSP, and if it's sodium, an EPSP.
EPSP.
Okay. And then how do you stop this process? Because these are going to be discrete events. So how does this end?
Reuptake?
Or reuptake's one.
What's
The
that other one?
transporter.
Enzymatic degradation.
Yeah, the reuptake is a transporter because the transporter takes it and puts it back.
Oh.
It's enzymatic degradation or breakdown, whatever you want to say. So there's this particular enzyme. Now that enzyme can be in the synapse
Mm-hmm.
or it could be in the presynaptic terminal. And I'm just repeating that because when we went through the neurotransmitters, we talked about how they were broken. Some of them were broken down, right?
But this process is not included on the essay. You just want.
Nope.
Okay.
This is
Reminders.
the review because if I'm giving you a break
Okay. No.
on your lab, I want to make sure that you get this part.
Oh, of
You know,
course.
because we're going to have to get some lab work done before we leave. We're not just going to be able to show you how to do it and then say you're on your own. Now we're going to have to get it done. Yeah, so this is just making sure you know that process. So now all we're doing is saying, okay, drugs change your behavior by changing your brain at the synapse. So how can these drugs affect a synapse? And so everything we just did, a drug can affect that process, right? And I've given you 11 of them here, and you have to be prepared to produce 9, right? So the first one, the drug serves as precursor. Someone take that. Who feels comfortable taking that? What is a precursor? What's the precursor for serotonin? You remember?
Hold on.
That's an acetylcholine.
Very good. Tryptophan. And so tryptophan is what makes serotonin. So a precursor is what makes the neurotransmitter. So if your drug is basically the precursor or can serve as a precursor, it means there's more precursor. There's more precursor, there's more what?
More production of a neurotransmitter.
More neurotransmitter.
Yeah.
More neurotransmitter, and then you walk through the process we just did, and not in that great detail. So you go more neurotransmitter, more to package into vesicles, more to release at the synapse, more to bind and activate postsynaptic receptors, which will give you either more EPSPs or IPSPs. Therefore, it's
Agonist.
agonist. Done. Got it?
Boom.
Well, we have to, like, are you gonna give, you're not gonna give us a specific neurotransmitter, are you?
No, you don't have to. You have
So we wouldn't have to
It's-
say if it's an IPSP or EPSP?
No, you just say either
Either or.
because you're
Okay.
covered, right?
Yeah.
So it's either gonna produce increase in EPSPs or IPSPs, because you don't know.
Okay.
So you can put both down.
So like the final answer is like agonist.
Mm-hmm.
Like that's what you're working towards. Okay.
That's what you're working towards, yeah. So the second one is the drug inactivates synthetic enzyme that is basically required to make the neurotransmitter. So the enzyme that's required, and the drug inactivates that.
It'd be an agonist.
Yeah, it's an antagonist, but why? Because
Less neurotransmitter.
there you go, and then you go through less neurotransmitter, less two. The first 2 or 3 are very redundant. But what happens is that if you don't understand the process, when you're explaining the ones that are further down, you make errors because you really don't know what you're saying. So I can pick out, basically, even though the redundancy may seem weird, but there's a reason for it. So you have less to package, less to do this, less to that, then fewer EPSP, IPSPs, therefore it's a
Antagonist.
Exactly.
I'm sorry, just like logistically, I'm confused about how to like formulate the answer. So, are we like literally like everything we're saying right now is what we write down, like the whole
in
process?
bullet form. In bullet form. So you'd say,
Okay.
you wouldn't say necessarily, these numbers mean nothing. One means nothing.
Okay.
So let's say you want to start with, I don't know what number it is, 9, did you say?
Yeah.
Okay.
start with 9.
Drug blocks the autoreceptors, okay? And it tells you right here, what if I asked you, if you blocked autoreceptors, what would be the result? You might think, it tells you, so it gives you a clue. It increases the synthesis or release of transmitter substances.
So that's agonist.
So it kind of tells you, and that's because the autoreceptors, remember, they sample, they keep that neurotransmitter levels at the synapse regulated. Yeah, they monitor. So so if you block that, then the cell's getting this false message. There's not enough. So what's it gonna do?
Produce more.
And that's what it does. So if it produces more, what does that mean? It's an agonist, exactly, but you have more neurotransmitter released, right? More to bind and activate, more APSPs and IPSPs. Exactly. So like, and now if I say, how about the drug stimulates postsynaptic receptors? So that's number 6. The drug stimulates postsynaptic receptors. Someone take that, it's easy.
Binds.
No, he's fine.
I don't know how you got it.
I just feel like, oh, go ahead. No, go ahead.
It's an agonist.
Go ahead.
It's an agonist.
I know that.
It's a direct agonist, actually, right? So it's an agonist, and why? Because you're going to have what?
More receptors
That are
for-
activated.
for the neurotransmitters to bind to.
Be careful, because the drug is in there activating it,
Ah,
right? Drug is in there activating it, so you're going to have more what? EPSPs or IPSPs. Therefore, it's an agonist.
So it's not
Done.
blocking
Which
it.
number?
No, it stimulates it.
It's just,
Yeah.
there's
Activating
there's
it.
a big difference there.
Yeah,
Between
because-
blocking and.
Because I think 7 is drug blocks it.
Okay.
Yeah.
Yeah.
Activates it. I didn't make this overhead, I would have said activates, not stimulates, but that's what it is. Right? See, when people don't quite understand it, then what I get is, therefore, there's more neurotransmitter release. No, does not affect neurotransmitter
No.
release,
because
right?
it's at the
binds.
postsynaptic.
Yeah, so wherever
It's nothing
the
to do with the
step is, you go there down, don't go
Okay.
back up. That's
Okay.
where students make a mistake, right? So you just focus on where the effect's happening, and then it has to be downstream.
Okay.
And that's why I'm gonna have a presynaptic terminal and a postsynaptic terminal, and when you give me your 1, 2, 3, 4s, whatever, you show me on the diagram where it's happening. Because that's another area where students are making mistakes.
So this diagram where the outlet is in?
Just, not that diagram, but it'll basically be a cartoon of a presynaptic terminal and a postsynaptic terminal. Just so that you're able to draw where it's going on.
And there's
So-
No.
nothing? Okay.
No, so the idea is if you understand the synapse, you're able to pull out the steps. You know, you don't have to write everything down, but you would, once you get comfortable, and you've done it already for one essay, so once you get comfortable with the material, you'll be able to say, well, maybe it'll block receptors, maybe it'll activate receptors, maybe block autoreceptors or activate them. Okay, so what about,
So I was gonna ask you, like, so for 10,
mhm.
do we go with 10?
No, do 10.
Alright, so 10, because the drug is blocking the reuptake, there's more neurotransmitters in the,
You got it?
what is it called? Postsynaptic cleft, so more EPSBs,
Yeah, well, binding and activating,
binding,
yep.
activate more EPSBs, IPSBs, hence is a agonist.
Yes, and just because it says blocks, you know how many times people tell me it's an antagonist?
Yeah,
Just don't get caught.
That's an easy
nah, I
mistake.
got that.
Huh?
That's an easy
Yeah.
mistake.
Easy mistake. So don't get, you know, like I know it's if it's the end bit that you're doing, if you do the other
Yeah.
part of the exam first, and you've got a little fatigue going, just make sure you don't make that mistake.
Okay.
Same with, okay, 11, drug inactivates acetylcholinesterase, and that's just an example. It's basically the enzyme that breaks down the neurotransmitter.
Because there's no breaking, I don't wanna answer again, let somebody else go.
You guys, how about someone from the faculty area?
Number 11,
11.
yeah,
Give it a go.
it's slide.
I see it. I just can you repeat it again?
Drug inactivates acetylcholinesterase, which essentially is the enzyme that breaks down neurotransmitter.
Sorry, this one's very complicated for me.
Anyone?
Well, I could go.
I think Brooke wants.
You can do it.
I could go, but
So we said
Go.
that there's two
really?
ways to get rid of the neurotransmitter in the cleft, right? So it doesn't keep binding and activating
get it.
receptors, because that wouldn't be good. And one is breakdown, or one is reuptake. And this is breakdown. So if you take the enzyme that breaks the things down and you get rid of it,
no,
it means you can't break the neurotransmitter down, right?
Right.
Which means there's more neurotransmitter in the
in
synaptic cleft,
Mm-hmm.
more
to
binding,
bind and activate receptors.
More
More
EPSB.
EPSB.
more IPSB.
Therefore, it's an
agonist.
I
There we
finally
go.
get it.
You see? There you go.
I got that one.
I told you.
I got that sucker.
We should do the next one.
No.
Does that make sense?
No.
So you guys, you got this.
Yeah.
You really do.
Are those gonna be the only
What about
options that are on
number-
here? Like the ones that are on the board right now, or would you have
That's
other?
for me,
No, I'm not going to give you anything, but just a cartoon of the presynaptic process. You
Oh,
can
so you
gonna
just
be a
pick
lot
which ones you
easier
want.
than
you
the
pick which
ones
ones you want.
So if we
like
wanted
in the
to do
ter-
like
in the
1 through
terminal
9,
stuff
we
like
could
that,
go 1
because you
through
gotta
9.
make sure.
Yeah, but remember the numbers mean nothing. I just had students that have decided to do 1 and 3 and 7 and they
Number
kept the
5.
numbers. I'm like,
Wanna do
they don't
5?
mean anything.
I should.
You know,
I
they
should
just
do
gave you numbers
Drug
up there,
inhibits
so
release
please just number them 1 through
transmitter
9 and then you
Is
choose
that just
whatever
a
you
neurotransmitter?
want. We could probably come up with more.
So
But the
it
picture will
inhibits the
be
release of the neurotransmitters.
Yeah, so there's
Some that looks very much like it, but it won't be that
And
picture.
and we draw the arrows in, or
No, so let's
Well,
they're-
you just number
Yeah,
them.
not
Okay.
actual
Okay.
It's corresponding to your numbers.
So
Got
When you
it.
like write it down when you only pick 9. I like this. It's fun.
Actually, it's best
Also, it's
if you don't even say drug inactivates acetylcholinesterase. You guys, you know, for this one with acetylcholinesterase, don't say drug inactivates acetylcholinesterase. Say drug breaks down the enzyme, or drug inactivates the enzyme that breaks down the neurotransmitter. It's just giving you an example.
Okay.
You really want to say, you know, because you want the class of drugs. You don't want, do you remember when we did, if you say no, remember when we did pharmacology and we did dopamine and we said that dopamine, norepinephrine, and epinephrine are from the same molecule, the same precursor? And the only thing that makes a difference between them is the enzyme that converts one into the other? Well, if you had a drug that blocked that enzyme, you wouldn't be able to have that other neurotransmitter around. Does that make sense?
Yeah.
So that's an example of how drugs affect enzymes. This is just affecting the enzyme that breaks it down. That's affecting the enzyme that makes it, which is the first one, the synthesis.
Okay.
Does that make, you know how I threw that up there because I said you don't have to memorize these chemical structures or the enzymes, but if you can just think about it it makes so much sense that, you know, just, an enzyme is needed to put things together to break them apart. And if drugs can go in there and monkey around with those enzymes, then, you know, you've got an effect there. And so 11 is best to say the drug inactivates the enzyme that's required to break down the neurotransmitter. Or the drug inactivates the enzyme that's required to make it. Okay?
Transmitter substance.
Yeah.
So you don't have to use the language exactly. You're telling me, you know the story, so you're just telling me where these drugs can have an effect.
Okay.
It really is building on your first essay. It's not difficult, but I think it's important because it strengthens. If someone were to say, what is your take-home message from this course, it would be to understand how a neuron works and how they communicate. Everything else is, you know, like the chemicals they use to do that, you know, or, you know, when they're together, the system, the, you know, the perception and the sensory system that gets activated. You know, but it's all the fundamentals how they communicate, and this is a good example.
I have a question. Is it pretty much like this? Is it like the same explanation for each one?
It can be.
Like the agonist versus
Mhm.
antagonist?
Mm-hmm. You might find that as you're writing it, it seems redundant on
Yeah.
some, but be careful.
Okay.
Because there are some that aren't. So it really tests that you know what you're talking about.
So is the agonist more like there's more
EPSPs and IPSPs?
well, yes, but neurotransmitters are binding to the postsynaptic.
Yeah, well, yes, you can say that, but not neurotransmitters necessarily. So up there, give me one that is not, it's an agonist, but it's not because more neurotransmitters are binding.
Well, like, I don't know, like the one that's like drug blocks reuptake. Would that count?
No, because it's still more neurotransmitters.
There's still more.
binding.
Oh, right. Okay.
But there's one that isn't.
What about 8?
No, that's
No.
more.
Seven?
No, because you still have more neurotransmitters binding.
Seven?
The synthetic.
Six.
6, yeah.
Because the drug's binding,
Oh.
right? So all of them, yeah, you're right, it is. But 6, the drug is actually mimicking the neurotransmitter. It's doing the job. But I can tell when people don't quite get that because then they say, so there's more neurotransmitter released. No, just stay down. Don't go back up. Okay?
Okay.
Does that make sense?
Mm-hmm.
So 6 would be a what?
They are.
It's
They
an
are.
agonist.
Even though I blocked them, but you wouldn't
Didn't
figure
you
that out
just say, like,
necessarily until after you played with it enough.
That's what I thought.
Oh, no, I thought.
We could use our laminated.
No, but this is an agonist.
Oh,
I didn't know that.
no. You already got that right in the last lab. I mean, come on.
Yeah, I wrote them down too.
You,
but
all
I
you,
don't really
the laminated
understand.
sheet has a lot of stuff on
You
it.
just have to
That's
talk
for you as a reference in the
Yeah.
future.
I mean,
Oh, no,
like,
no, no. that's
Just
okay.
pay attention to the PowerPoints. Yeah.
Yeah.
And that's pretty simple. You got neurotransmitters represented on one PowerPoint. There's a lot of stuff on there. And we're going to build on that next semester. But if you've got those down, if you remember, you know, dopamine is really important in ganglia and
I was
also for
thinking of
affect
talking to them.
and for attention, then when we start talking about those things, you'll be like, oh yeah, I remember this sort of thing.
This
Told you
is
it wasn't
not
hard,
necessarily the
though.
essay, but do you have any like
I don't think it was.
suggestions for studying for the multiple choice part? Or
Yeah.
I don't know if that's a question like you would have to answer, but
Just look at your PowerPoints. Go
Okay.
through every PowerPoint.
okay.
You'll be fine.
Will you be asking like specific questions about like the drugs that are on there, or
Those drugs? Or which drugs are you referring to?
Like the laminated sheet.
like what was
I forgot about that.
like maybe there's PowerPoint and the other ones. There's like
Can you show me, tell me what you're referring to, because I don't want to answer it thinking, I know what you're asking. These drugs, some of them are drugs, some of them aren't. So like venom isn't really a drug, but it can be, you can think of it as, you know, an outside chemical. You are not responsible for these. Remember how I said that you don't have to use them as examples? It's just for you to put it in context.
There's quite a few slides on this PowerPoint with the different,
Nuclei?
yeah.
And again, when I lectured,
Yeah,
I
you
said, you don't need to
okay.
know that, but I want you to see
Right.
that there's a pattern here, that the nuclei for these neurotransmitters are located, for the most part, you know, in the back, in the caudal, and then course through and release. And so these neurotransmitters throughout your brain. But if we're talking about dopamine, let's do that. Where would you expect dopamine to be released in the brain? I just said it. Well, yeah, so it's involved in movement, so think what it's involved in. And so where's movement mediated?
I'm just making up stuff.
Clearly. You
Yeah,
trying to sound smart on the
basal
camera.
basal ganglia,
No, I
right?
don't
The
need to
basal
try.
ganglia. And dopamine is also very important for reward and emotion. So where would you think?
Amygdala.
Yes, right? Or the reward pathway, so nucleus accumbens, whatever. But yeah,
yeah.
so that's why I showed you that. So you can see that we know, you know, the function of this neurotransmitter, thank God, lies right with where it's located, or else we couldn't make sense of anything. You know. Acetylcholine is really important for memory, and it better be located in the hippocampus. And it is. If it wasn't, we'd be like, uh-oh. So yeah, those sagittal sections of the brain showing you the neurotransmitters, you don't need to know that. So they're in there, and if you want to print them out and cross them off just for the exam, but it's always just good for you to have
Visually.
this, to have this knowledge, not just because I'm going to test you, but have this knowledge that these neurotransmitters, you know, they start off with, you know, a nucleus of these neurons, the noradrenergic neurons, the dopaminergic neurons that secrete this stuff, but they you know, have axons and projections all throughout the brain, and that's where they release their neurotransmitter.
Okay.
Anything else? You know, obviously the precursors, the receptors for particular. Oh, did you come up with another drug? What you were talking about?
On the slide, it says like,
Oh, for the pathologies, yeah. We will be going through schizophrenia in a lot more detail. No, you don't need these drugs.
okay.
But just, it would be very important for you to know that dopamine receptors are, and the fact that it's too much dopamine, like you wrote, exactly. And the difference between the Parkinson's and the schizophrenia is that too much dopamine in the mesolimbic or mesocortical area, you get these hallucinations and delusions, schizophrenia. But, you know, if you give a drug that blocks that, gotta be careful, because what? Your patient starts presenting with, if your patient has too much dopamine and you give them a drug that starts blocking it, they start showing you Parkinson's-like symptoms. Same with the Parkinson's patient. You know, it's got a motor disorder, not enough dopamine, you give them more, all of a sudden they're starting to have hallucinations and delusions, and it's because it's just in the Parkinson's patient, too little dopamine in nigrostriatal, in the basal ganglia. But the dopamine that's in mesocortical or mesolimbic is fine. And vice versa, possibly, with a schizophrenic. But when you take something orally, it goes where? Everywhere, right? It goes everywhere. And so that's why I started to present the receptor subtypes, because that's how pharmacology is going to be able to, you know, they already have designed drugs that will just hit the mesolimbic and leave the nigrostriatal alone, hopefully. Well, it's not as great as they expect it to be, because it isn't that tidy, but it's a start. Okay?
Okay.
But when we branch out, you know, some of you may actually want to do schizophrenia, the case study stuff. Like, we can't have multiples, this is really fun, but we'll get into more detail. And then you might have to explain what dopamine receptors are, because we already know. Any other questions? So what chapters are we covering? Farm,
Five,
Six.
seven.
which
No,
which
4, 5,
are
and 7.
Forest
pharmacology,
Vision,
vision,
and sensory.
sensory motor, which was the motor, we extended that, right?
Yep.
And not the vestibular auditory, that's gonna be what we
Next.
start off with next
Okay.
term. After a very brief
Review.
review. You guys are doing the review, brief. Actually, there's, we'll see how we wanna do it.
7.
Okay.
Mhm.
Got it?
Yeah, I'm comfortable.